Today I will go through the day 8 problems with you just in case you need a little extra help kind of sorting out all of those words and trying to figure out exactly what they're saying. You don't have to write out the problems the same way I'm writing them out. I'm doing that to try and put it in a form so that you can really see what's going on so that you can understand and get the problems worked a little bit easier. If you can read the problem and do it in your head for this type of problem, that's fine. So we're going to start with comprehension check number 9, and it says if a chemist reacts 6.4 grams of copper with 1.6 grams of oxygen, cupric oxide is made. It is composed of 1 copper atom and 1 oxygen atom. So I have taken those first couple of sentences and I put them in order here. 6.4 grams of copper is reacted with 1.6 grams of oxygen, and it forms a compound that has 1 copper atom and 1 oxygen atom. Okay, then it says, however, copper and oxygen can also combine to make cuprous oxide, which is made of 2 copper atoms and 1 oxygen atom. Okay, so here's my 2 copper atoms and my 1 oxygen atom. That's going to be different in the second compound. Suppose you react 1.6 grams of oxygen with copper to make cuprous oxide. How many grams of copper would you have to use? Okay, so when I look at this, I can see that my oxygen is the same in both situations. So therefore, the oxygen atoms are the same in both situations as well. And they'd already told me that the number of oxygen atoms was the same. So what I need to compare is my copper. I went from 1 copper atom to 2 copper atoms. So obviously I'm going to need twice as much copper. So if I had 6.4 grams of copper before, I am now going to require 12.8 grams of copper in order to make that particular compound. Okay, just a simple multiplication by 2. All right, let's flip back to the review questions and we'll look at number 12. Number 12 says a chemist makes 2 different compounds from the same 2 elements, tin and chlorine. He reacts 50 grams of tin with 29.87 grams of chlorine. There are no leftovers from either element. That's always nice when they can tell us that. And he then reacts 50 grams of tin with 59.74 grams of chlorine. Once again, there are no leftovers. Thank goodness. Makes things much easier for us. If the first compound has 2 atoms of chlorine in the molecule, how many atoms of chlorine are in a molecule of the second compound? So we don't have quite as much information, but I don't need as much in order to solve the problem that they'd asked me. So here's the first compound that he made, the 50 grams of tin, 29.87 grams of chlorine. I know that this one has 2 atoms of chlorine in it. Here I've got the 50 grams of tin, 59.7 grams of chlorine. The tin has stayed the same. I don't know how many atoms it is, but it doesn't matter because they've only asked me how many atoms of chlorine there are going to be here. So if I look at those 2 numbers, 29.87 and 59.74, now in a problem like that, I kind of look at it and go, well, that's really close to 30, and that's, if I round that, that's really close to 60, so I suspect it's probably a factor of 2. And if you take your calculator and you divide these 2 numbers by each other, you will find that that's exactly what it is. It is a factor of 2 because the 59.74 divided by 29.87 does give you 2, and so therefore, because it's a factor of 2 difference, I'm going from 2 atoms of chlorine in the first compound to 4 atoms of chlorine in the second compound. All right, number 13. A chemist is making 2 different compounds from the same 2 elements, nitrogen and oxygen this time. To make the first gas, she reacts 10 grams of nitrogen and 11.42 grams of oxygen to make 21.42 grams of the first gas. Okay, so I have that information up here for the first reaction. Suppose she starts with 10 grams of nitrogen again, so that part's the same, but she wants to make a completely different gas with no leftover oxygen. And so then they give me 3 samples or 3 numbers of which one of these should I potentially use. 20.5, 22.84, 35.12. Well, if I look at this 11.42, we've seen before that I always have to multiply that by some sort of whole number. If I multiply that by 2, I'm going to get 22.84. If you can't do it in your head, do it on your calculator. Just go ahead and multiply that out by 2. And 22.84 is actually one of the choices that they have there. If I multiply it by 3, that doesn't give me any of the choices that I have. So the correct answer there is going to be the 22.84 grams of oxygen, simply because I've gotten that answer by multiplying the original one by 2, because it needs to be a whole number ratio. That's what the law of multiple proportions tells us. All right, then we've moved on to the extra problems. Problem 3D. Now, we've worked 3A, B, and C already, so you're going to have to pull your homework out from a couple days ago when we did those problems so you can find the numbers that you're going to need. It says if the compound made in A, so here's the compound made in A. We used 63.55 grams of copper and 70.90 grams of chlorine. Again, I just took that from the problems that we worked the other day. It is composed of 1 copper atom and 2 chlorine atoms. How many chlorine atoms are made in the compound in C? Well, in the compound in C, I used 63.55 grams of copper, so you can see the copper was the same. I used 35.45 grams of chlorine. So therefore, since the copper was the same, the number of copper atoms is going to be the same. What kind of ratio do you see between these two numbers? Well, again, if you don't see it off the top of your head, take your calculator and divide those two numbers out. 2 times 35 is 70, so I've actually divided this by 2, and so therefore if the first example had 2 chlorine atoms, then that means that the compound in part C is going to have 1 chlorine atom. Okay. Number 5. The compound in number 4, which again you're going to have to kind of go back and look and see what you did in number 4. The compound in number 4 is composed of 1 silicon atom and 2 oxygen atoms. So I went back to number 4. I said, okay, well, I used 28.09 grams of silicon. I used 32 grams of oxygen. Again, that was from number 4. And so that gave me 1 silicon atom and 2 oxygen atoms. If a chemist reacts 28.09 grams of silicon, how convenient, those two numbers were the same, and 16 grams of oxygen to make a different compound with no leftovers, and the no leftovers part is key, how many oxygen atoms are in this compound? Well, again, what kind of simple relationship do you see between the 32 and the 16? If I take 32 and I divide it by 2, I'm going to come up with 16. So that means I'm going to have to take that 2 and divide it by 2 also. So that means that in this one, I'm going to have 1 oxygen atom in this one. Okay? And finally, number 6. A chemist is making 2 different compounds from the same 2 elements, nitrogen and oxygen. To make the first gas, she reacts 14.01 grams of nitrogen and 16 grams of oxygen to make 30.01 grams of the first gas, which is composed of 1 nitrogen atom and 1 oxygen atom. So I don't really need the total of that one. It doesn't help me out as far as the actual problem that I'm working. Suppose she starts with 14.01 grams of nitrogen. Again, that fixed amount is important. But this time she wants to make a gas composed of 1 atom of nitrogen and 3 atoms of oxygen. What mass of oxygen should she use so that there are no leftovers? So nitrogen is the same in both of them. I had 1 oxygen atom here. I've got 3 down here. So that means I'm going to have to use 3 times as much oxygen as I had before. So if you take 3 times 16, you are going to end up with 48 grams of oxygen is what you're going to need to use to make that second compound. All right, so that takes care of the problems for day 8.